Welcome students to Module 3. This module is an introduction to valuation in the sense that it presents the concept of time value of money. One of the most fundamental concepts in finance is the time value of money. In fact, this concept underlies the operations of all financial markets. Managers also need tools that enable them to make appropriate comparisons between the dollar cost and benefits of different actions over time. In essence, the time value of money allows us to forecast that future and appreciate the ramification of future conditions today. It also enables us to make comparison between projects or investments, for example, compare apples with apples. This is essential if we are to make meaningful and accurate decisions in finance. In this module, we will learn about future and present values and about compounding and discounting. So to calculate future values, we compound, and to calculate present values, we discount. Then we move on to calculate the present and future values of multiple cash flows when those cash flows are of equal value or unequal values. That will lead us into annuities and perpetuities, and will close by differentiating between effective annual rates and nominal or stated interest rates. This is how present and future values are used in practice. These consulting firms, Mayrick and Associates, a consulting group together with Econ Search and Steer Davis Cleave, presented a report to the Victorian government on a range of transport options for the East-West link. The report summarized extensive analysis undertaken to evaluate the benefits and costs of developing the new transport infrastructure options, and described a series of present values that have been determined. The present values were determined by, first of all, estimating revenue per day for the base case and for each option, estimating revenue per year for each option, discounting the future cash flows to the present, estimating the yearly increase of revenues for each option, and calculating the difference between the base case and each option to see the incremental value added. What does time value of money mean? Well, it means that $1 received today is worth more than $1 received tomorrow. Have a look at this question. What would you prefer? $1,000 today or $1,000 3 years later? Of course, we want the money now. Why is that? Because if we invest this money at, say, 5% for 3 years, we will have more. That's what we mean by time value of money. By receiving $1,000 today, we invest it and make it grow. We earn interest on it. If we decide to receive $1,000 in 3 years' time, we forgo that interest that we can earn in the meantime. Also, because of inflation, over time the real value of financial assets will fall relative to their nominal value. This means the purchasing power of money falls over time, thereby encouraging us to bring our consumption decision forward or spend now rather than later. Furthermore, there is a distinction in finance between risk-free and risky cash flows. Most future cash flows have some element of risk in that the person who makes the promise to pay you cash may default or modify payments because of unforeseen circumstances that may have risen. Money, therefore, is worth more now because it avoids this risk. This is the terminology we use in this module. Present value is the current value of some future sum. The opposite, the future value, is the value of an investment after one or more periods. N represents the number of years, while M stands for the number of compounding or discounting periods in a year. R is the interest rate, also known as the discount or compound rate. Discounting is the process of reducing a future value to present, while compounding is the process of accumulating interest in an investment over time. All time value questions involve 4 items: a present value, a future value, R, and N. Given 3, it is always possible to calculate the missing value, the 4th one, using algebra. Here we also differentiate between compound and simple interest. Compound interest is calculated on both principal and any interest accumulated, as opposed to simple interest, which is calculated only on the principal. The difference between these two is called interest on interest. This is a graphical representation on the present value and the future value concepts. So when we talk about compounding, we take our today's money into the future. We calculate future values. We're compounding. And when we talk about discounting, we bring the future money in today's values. We calculate present values. Let's start with future values of a single sum. If we have $100 to invest at 10% for 5 years, what is the value of our investment in the future in 5 years' time? If we calculate year by year using compounding interest, we observe that is $161.05. This value is made up by the original principal, $100, and the compound interest, made of all those yearly interest added to 61.05. If we calculate the future value using the simple interest method, the future value is only $150, made up of the original 100 and the simple interest of $50. The difference between the two values is just $11.05, and this we call it interest on interest value. Note that if we increase the number of years or the number of compounding periods, the future values also increase, giving us a positive relationship between future value and time. So the longer the periods, the higher the future value is. This is the general formula for future value. Have a go and solve this in your calculators. And if you have a computer, you can use Excel formulas as presented in this screenshot to solve for the future value. Open an Excel spreadsheet, then in the toolbar, click on Function button and search for future value. Now recalculate the same problem, but here use instead 12% interest. What would be the future value if the interest rate is 12%? The answer is $176.23. This example really shows the difference between simple and compounding interest. It is a bit extreme, but it shows the power of compounding. Suppose you had a relative deposit, $10 at 5.5% per annum interest 200 years ago. How much would the investment be worth today? When applying the formula, we see that the future value of those only $10 is over $447,000. Note that with simple interest, after all those years, you only get just $120 compared with $447,000 using the compounding interest method. Very powerful example showing the power of compounding. Now suppose this $100 investment account earns an interest rate that is compounded more than once per year. What would be the future value then? Here in the formula, first we need to convert the interest rate into interest rates per period and the number of years into numbers of periods. And we have some examples from semi-annual compounding to continuous compounding. In your calculator, you have a button with the exponential function e, which is a mathematical constant and has a value of 2.71828. So if we have multiple compounding periods per year, the total periods that you use in calculation become greater as we multiply, and the interest rate becomes smaller as we divide the original interest rate by the number of compounding periods per year. Now take some time to solve these problems. Suppose you have $500 to invest and you believe that you can earn 8% per year over the next 15 years. How much would you have at the end of the 15 years using compounding interest? And recalculate again, how much would you have using interest, simple interest? Then I want you to solve the same problem if you have the same rate, 8%, but is compounded semi-annually. What would be the end result? Please take time to do these calculations using your calculator or your computer. We move on now to find how to calculate present values, or in other words, the value of an investment in today's money. For example, if you want to buy a house in 10 years' time, that you know it's going to be around $500,000, for example, how much money should you invest now in order to have that kind of money in 10 years' time? From the future value formula, we can rearrange the terms to isolate present value, which is just the future value divided by 1 plus r at the power of n. It is the reverse of finding the future value. And note here how the formula is written in many formats. To remove the negative exponent, you just transform into a fraction. So for example, if you need $1,000 in 1 year, and the interest on investment is 10%, how much do you need to invest now? Applying the present value formula, we find that about $909 we need to put in the bank now. Another term that is often used when calculating present values is discounting, because we bring back or reduce a future value to the present. Therefore, when dealing with finding the present value, we can also say the interest rate is the discount rate. This is a very important concept in finance. I cannot stress enough how important this is, because this concept is used in the valuation of assets. Now imagine that you have a rich benefactor that promises to give you $100,000. If the interest rate is 6% and the benefactor is thinking to give you the money in 1 year's time, or 5 years' time, or 10 years, or so on, what would be the present value of that $100,000 to be received in the future? So everything stays the same, only the variable n, the time, will change. By applying the formula, we observe that the present value decreases as we increase the number of discounting periods. So the larger the n is, the smaller the present value will be. We can say that there is an inverse relationship between the present values and time. The longer the time, the smaller the value becomes. Now consider that your benefactor settles to give you the money in 10 years' time. However, there is a change in the interest rates. How does this affect the present value? Again, here the only thing that changes is the rate, everything else is constant. And we observe again that we have an inverse relationship between the rate and present value. As the rate increases, the value decreases. These are important relationships to remember, especially when we get to bond valuation in our next module. Please take time to solve another quiz. The first problem, suppose you need 15,000 in 3 years. If you can earn 6% annually, how much do you need to invest today? So what are you trying to find? Is it a future value or is it a present value? Once you decide, write down the formula and the inputs and use your calculator or the computer to solve. You will find the answer to be 12,594 and 46 cents. Therefore, we are calculating a present value as we are reducing the 15 years received in 3 years in today's money. The second problem, if you could invest the money at 8%, would you have to invest more or less than at 6%? How much? The first part of the question you can answer without calculation. Remember the inverse relationship, the higher the rate, the lower the present value. So in this case you need to invest less. How much less? We apply the same formula, the same present value formula, and we change only the rate. So the higher the rate, the lower the answer will be, as opposed to the answer of the first problem. The answer it is 11,907 and 48 cents. Now we move on finding the future values and present values when we have multiple cash flows. And we'll go straight into it and start with an example. Before we asked how much is 1,000 invested at 6% to be received at the end of 3 years. Now we ask how much is the value of an investment in 3 years' time if we deposit different amounts each year. We can solve this kind of problems either by compounding the accumulated balance forward 1 year at a time, as shown in solution number 1, or by calculating the future value of each cash flow first and then totaling them as shown in solution number 2. We will get the same answer. This is a graphical representation of the two solutions. Drawing a timeline is very useful, especially if we have scattered cash flows, in the sense that we have a gap of no deposit for a few years and then we start again. You can easily make errors if you don't have a timeline, as you don't know how many times to compound the remaining cash flows. And here we have an example on how to calculate the present value of uneven cash flows. Again, we can solve by either discounting back 1 year at a time, as presented in solution number 1, or calculating the present value of each cash flow first and then totaling them as presented in solution number 2. Again, the result should equal using either method.